Swagwan, it's Patrick Starfish from Fortnite here. Today we're going to be looking at what are we looking today? We're looking at 64-bit assembly arithmetic addition or arithmetic something. Declare our data, our variables, reserve our buffer space. All very simple. Call our. There's note that we're using external functions printf and scanf from the C standard library. We are telling the linker up here. Obviously, we need to use them files. Now, if we move into the actual main program, we can see that we are using the SSE stack. So of course we're using movsd xmem0 and then to perform our functions. xmem0 is a very cool. The xmem registers are quite cool registers. They are up to 128 bits wide and can be used to store and operate on any floating point numbers, as well as loads of other types of data. There are 16 XMM registers, XMM 0 through 15, and they can be used for either scalar or vector operations, obviously depending on what your use case is. But very, very useful registers for these if you need large amounts of data processed at once. Now, let's take a look at how we are going to be doing this. So the add SD instruction, very, very simple. This is just using scalar double precision. This function provides the ability to add scalar double precision floating point values together. It takes two operands: the destination operand and XMM register in this case. Obviously, we want to be storing quite a large data chunk, and then the source operand. So this could be, in this case, which would be our buffer, where our results are stored. So let's take a look. Once we have processed this, we are then just going to store it in our result, in our result variable. We're not using that in our code at the moment. This is a very simple program, but it's just nice to show how we would do that. We can simply copy everything that's in xmem0 over into a new variable, and we have that stored later. Now we can just print our result out and exit the program, and this should now function as expected. We can enter our number, so 1, 1 like that. And then 3.3534, whatever. And now we have our answer there. I hope this was a good intro to the SSE stack and how these instructions and extensions function. Obviously, any comments, leave them. Any questions, leave them in the comments, and we'll see what we can do. We'll get back to you with some great answers. We have a team of specialized Soviet spies. And they will find you, and you cannot hide. So I think that's all for today's video. I'll see you in roughly about 5 minutes.